Good. There we go. All right. So for these three, again, it's really the same idea as the previous examples we just did, right? So for the first one, we want two numbers whose product is 40 and the sum is 14, right? Okay, so what two numbers give us a product of 40 and a sum of 14? Well, as you can see on the slide, 10 and 4. Remember, if you do get a pair and it doesn't work, try something else. It's possible that no pair is going to, oh boy. How did that happen? Stop sharing. Stop sharing. Let me just fix that. Okay. I mean, it is possible that there may not be a pair. In that case, the polynomial cannot be factored. Okay. That can happen. All right. Okay, so again, we get 10 and 4, because 10 and 4, again, the product is 40, and the sum is 14. Okay? All right, so that's what we get. So now we can factor this, namely, we get this factorization, x plus 10 times x plus 4. You know, that's what we get here. Yeah?
Does it matter which one goes first? Like, you could do x plus 4 and then x plus 10, right?
Right, it doesn't matter.
Okay.
Okay? Awesome question. So, right, if we did x plus 4, then x plus 10, that's fine. You know, multiplication you can do in any order you want, so awesome. Okay. If you can't see the slides, please tell me. Okay. All right, so again, you could just check and, you know, the answer is what it should be. If you do it right, you get the original polynomial back. All right, good. Any other questions? Yeah?
So we leave it as x plus 10 and then x plus 4?
Right, times, yeah, that's it.
So where does the x, oh, okay, never mind, I understand now.
Okay, awesome. Okay. All right, let's keep going. So let's do this one, x squared plus 13x plus 40. I mean, if you try 10 and 4 here, it wouldn't work. 10 and 4, right? Because again, we need two numbers whose product is 40 and whose sum is 13. So here we want two numbers whose product is 40 and whose sum is 13. Okay, what two numbers do that? Well, again, you might think, oh, 10 and 4. Well, those are not going to work because the sum has to be 13. But as you can see here, 8 and 5 will work. Eight and 5 will work. Okay, right? Because their product is 40 and their sum is 13. So here we go. So again, that's what we get. So we get this is equal to x plus 8 times x plus 5. And again, if you wrote it the other way, that's fine also. Either way, when you multiply it, you'll get the original polynomial back. Right, that's fun. Okay, let's do the last one. So the last one's a little different. The last one might have been a little tricky. X squared minus 13x plus 20. I mean, for this one, you want two numbers whose product is 20, but the sum is negative 13. Okay, well, are there two numbers that do that? Well, again, here you would have to check all products of integers that give you 20. Well, 10 and 2, that gives you 20. That sum is not negative 13. Same thing with negative 10 and negative 2, right? That doesn't give you, I mean, the product is still 20. That doesn't give you negative 13. You can see 5 and 4, That doesn't work either. Neither does -5 and -4. 20 and 1. That doesn't work. So to me, at least, it looks like there are no pair of numbers that work. And so this cannot be factored then. So this cannot be factored. Okay, that's good. So again, if you can't find a pair of numbers that works, if you cannot find a pair of numbers that work, then it cannot be factored. Okay. Are there any questions on this? I was going to do some more examples than the worksheet, but let me just point this out. We've had formulas. I think we actually have seen this formula before. X squared minus b squared equals x minus b times x plus b. But you can use this formula to factor. Namely, if you have a difference of two squares, if you have x squared minus a perfect square, you know, a perfect square is an integer that's a square of something else. In other words, if you have x squared minus b squared for some integer b, then you can factor it like this. For instance, if you have x squared minus 9, well, 9 is a perfect square. 9 is equal to 3 squared. Remember, b has to be an integer. So we have 9 is equal to 3 squared. So we have x squared minus 3 squared. And so we get x minus 3 times x plus 3. That is what we get. Okay, that's great. We have x, what about x squared minus 36? Well, that works because 36 is a perfect square. 36 is 6 squared, right? So we have x squared minus 6 squared, which is x minus 6 times x plus 6. Right, so again, with 36, 36 is 6 squared. So we have x squared minus 6 squared, which is x minus 6 times x plus 6. Now that's for a difference of two perfect squares. A sum, however, you cannot factor, mostly because we're not working with complex numbers. We're only focusing on real numbers. But x squared plus b squared, you cannot factor that. Okay. All right, so I figured it'd be good to do some backup examples. Okay, so let's just do that, and then I'll put the worksheet up, although you should have the worksheet already. And I will post solutions to it as well. We'll go through the solutions as well. But let's consider this one. X squared plus 17x plus 60. So as you can see on the slide, right, we want two numbers whose product is 60, the constant term, and the sum is 17, the coefficient of x. Product, sum. Product, sum. Okay, what two numbers do that? Well, you might think, oh, well, 30 and 2, right? 30 times 2 is 60, but that's not going to work, though, because 30 plus 2, well, that's equal to 32. It's not equal to 17, in other words. It's not equal to 17. So 30 and 2 do not work. Okay, well, is there a pair that's going to work? Well, what about 12 and 5? I don't know why 12 and 5 were here. Sorry about that. That's typo. But 12 times 5 is 60, right? And 12 plus 5 is 17. So these numbers do work, and we get the polynomial is x plus 12 times x plus 5. And so we do get that. Good. And so because of, and you know, again, I check as well. So that's what we get. Okay, let me just get the recording. Why doesn't it do that? Here we go. Okay. All right, let's do another one. So for this one, we have x squared plus 12x plus 36. We have that. And so now we want two numbers whose product is 36 and the sum is 12. And hopefully it's easy to see what's going to, well, I mean, because it's on the slide. But even if it wasn't on the slide, hopefully you can find the numbers. It turns out it would be 6 and 6, right? We know 6 times 6, 6 squared is 36. We also know 6 plus 6 is 12. So in other words, 6 and 6 are going to work. And so that tells us this is equal to x plus 6 times x plus 6. And again, we just check. Okay, so again, we want two numbers whose product is 36 and the sum is 12. Product, sum. Okay, so 6 and 6, that's why they work. 6 times 6 is 36. 6 plus 6 is 12. And again, we just check here. And that's why it works. You know, if you multiply this out, you get the polynomial. Any questions on this? Okay, so let me post the worksheet. Also, I forgot to tell the other class this, but I did post some practice questions from the textbook on Blackboard. I posted for the 3rd edition and the 4th edition of the book. Just like, you know. Let me get the worksheet. So stop sharing that. Here it is. So I figured we'd take about like maybe 5 or 6 minutes to work on this, maybe 10 minutes at most, and then we'll go through together. Okay. All right, so that's what we're going to do now. Let me stop the recording.